Okay, are you able to see my screen share, guys? Happy New Year. I think first class in the new year, I think, right?
Yes, sir.
Yeah, we didn't have one last. Yeah, I was out. I was sick. Okay, all right. So let's start from the beginning anyway, even though some of the initial questions are trivial. So the first one is Kathy. I don't know, some random paper I'm just displaying here. Here. Okay, all right. So let's, for completeness, we'll do some of the easy questions also, even though some of them are very trivial. Kathy's shop is making golf trophy. She has 600 dimples on a golf ball. It takes 4 seconds to paint one dimple. How many minutes does it take to paint the whole thing? So 600 into 4 is the number of seconds, right? So 600 into 4, which is 2,400 seconds. And then we just have to divide it by 60 to get the number of minutes, which is 40 minutes. Okay, so this is some random person's paper here. There could be mistakes. It's just coincident that this answer is right. But as we go along, there might be mistakes. So I randomly picked up someone's worksheet. Okay. Second one. And as we go along, I'll probably make small variants if possible.
So I just wanted to say I forgot to send my codes. I've done the papers, so I just send them before.
That's fine. I've lost track. Whoever has sent, that's great. I've been sending as soon as I've got responses back from them, from this org that I'm partnering with to get the tests. I'm sending it along. That's fine. You can just send it later. Is it Arsh, right? Okay. Yeah.
Yes, sir.
Okay. I'm thinking of two whole numbers. Their product is 132 and the sum is 23. Okay. So not many numbers with product of 132. You should be able to quickly realize it's 12 times 11, right? In fact, 12 plus 11 is 132, is 23. Even if you didn't realize, you can just start factorizing 132 as 2 into 66, 3 into 44, and so on. So clearly, if the sum has to be 23, the numbers have to be fairly small. And then you'll soon end up at 11 into 12 is a product. And then 23, therefore, is the sum. Okay, so quick question on this one. How many different sums are possible? So in this case, the sum is 23. How many different sums are possible for sum of two factors of which multiply to 132? Okay, so I'll give you guys 20 seconds to do this.
Sorry, what did you ask?
So in this case, the product of the two factors is 132 and the sum is 23. Now, if the product remains 132, how many different sums are possible? For example, 133 is a sum.
So 6.
6. Okay. Anyone else?
I got 6 as well.
I
Six
got
as-
it as well.
6.
Okay. Yeah. It's essentially the question is asking how many different pairs of factors there are, right? So we can either list out all the factors of 132. It's a small number, right? We can continue to do this along this 2, 6, 4, 33, and so on. Or by prime factorization, you can count the number of factors. That might be easy, right? So this is 12 times 11, and this is 4 times 3, and the 11 is already prime. So this is 2 square. So 2 square. So the number is 2 square into 3 power 1 into 11 power 1. So that's the 132. Now, how many factors does it have? Just add 1 to each of these powers and then multiply, right? So it's 3 into 2 into 2, 6, 12 factors. And therefore, you can club them in 6 pairs. And each pair will give a unique sum, right? When the numbers are far apart, the sum will be large. Like 1 and 132, the sum is largest. Okay. All right. So that was question 1.2. Okay. For what numbers will we have? So this number is 12. This number is 6, right? This number is 6 different sums. Okay, fine. Ignore. I thought I'll just have another question. Let's go for the next one. Question 3. Frank. Gary has 126. Frank has 4 more than Emily, and Emily has 2/3 as much as Gary. How many dollars does Frank have? So again, fairly basic, right? We can start from the end. Emily has 2/3 as much as Gary. So Emily would have 2/3 of 126, right? And 126 goes 42 times. Therefore, this is 84. So Emily has 84, and then Frank has 4 more than Emily. So this is 88. We just have to be careful and not make silly mistakes. That's it. So that is question 3. Question 4. So who is not talking? Please, can you mute? I hear a bit of a noise. I don't know who it is. Okay, the digits 2, 3, 5, 6, 9 are each used once to form the greatest possible odd 5-digit number. Greatest possible, right? So obviously the greatest possible number without odd or even would be 26352, right? Sorry, 96532. Now he wants the greatest possible odd 5-digit number. So you'll just swap, right? So you'll just make this 2 and this is 3. And then the tens place is therefore 2. Okay. Okay, let me ask a question on this one. Okay, so what are the odd numbers here? 3, 5, and 9. 3, 5. Okay, all right. How many 5-digit numbers can be formed using these such that every odd place is occupied by an odd digit and every even place is occupied by an even digit? Okay, so
Every odd places.
every odd place is occupied by an odd number and every even place is occupied by an even number.
Okay.
How many 5-digit numbers using each digit only once?
It's a 12.
12. Okay, Nitya says 12.
So 12.
12 as well. Okay.
So 12.
12.
Okay. All right. Fairly easy, right? So there are
12, sir.
so there are three places here, and there are 3 odd digits, 9, 5, and 3. I can arrange them in any of the 3 factorial ways, 6 ways to arrange them. Having done that, in the 2 other places, I have 2 even numbers left. I can arrange them in 2 ways. So 6 into 2, which is 12 ways. Okay. How many of these? Okay, all right. I'm resetting the question. Again, the same 5 digits. How many 5-digit numbers are divisible by 4 using these digits exactly once?
So can you repeat your question?
How many 5-digit numbers using these three 5 digits exactly once are divisible by 4?
Sir, I just joined due to network issues. So, what paper are we doing?
We are doing this mock 11, and right now we are on the question 4 and few small variants of those questions.
Okay, sir.
So are you talking about fifth? So the question which you just gave, is it 4-digit or 5-digit? So the question which you just gave, is it for 4-digit numbers or 5-digit numbers?
For 5-digit numbers. 5-digit numbers using 2, 3, 5, 6, and 9, each digit exactly once. How many of them are divisible by the number 4?
So they have to be with these digits.
With these digits, yeah. Yeah, anyone? Ranveer, any answer?
Yeah, one.
Sir, 18.
18, okay.
I'm getting 6.
Sir,
6,
36.
So six.
36, 6. Okay, another 15 seconds and we'll discuss.
So I'm getting 27.
27.
Sir,
36.
36. Sir, 36. I changed my answer to
36.
36.
So
36.
So 36.
Okay,
36.
all right. All right, multiple 36s. Okay, let's discuss. So 1, 2, 3, 4, 5. It must be divisible by 4, right? Obviously, it must be even.
Sir.
That means
I got 144.
144. Okay. All right. It must be even, first of all. So it must end in either 2 or 6. Okay. Now, if it ends in 2, for it to be divisible by 4, this place can be either 32, or rather, this can be either 3 and therefore 32, or 52, or 92. These are the only possibilities, right? 62 is not divisible. Similarly, if it's ending in 6 here, right? 36 is divisible by 4, 56 is divisible by 4, 96 is divisible by 4. Okay, now these are very similar. So let's count this, and then literally the exact same scenario is going to happen here as well, right? So in this case, if I have to count the number of numbers, I've locked 2 in the first place. So there's only one way. I can put any one of the 3 digits, 3, 5, or 9 in the previous digit. Now I've used up 2 of the digits. Now the remaining 3 digits can be in any way, right? So I can arrange them in 3 factorial ways. So I have 6 into, what is this antivirus here? So I have 6 into 3 into 1, which is 18 ways. And then, like I said, exactly same, another set of 18 ways coming from here. So total of 36 indeed. Okay, cool. Whoever got other answers, you can check where you went wrong, or you can ask, or maybe I'll just randomly pick up something. Sukrit, 144 seems like too big, right? Did you find your mistake?
Yes, sir.
Okay, all right. Do you want to share what the mistake was?
Sir, so instead of doing 3 factorial, I did 4 factorial by mistake.
Okay, and therefore your answer was 4 times bigger. Okay, understood. And Ranveer, you got 6. What was your mistake?
Oh, I forgot. I did not multiply it by 3 factorial into 2.
Okay, all right. You didn't multiply by 3 factorial at all. You just kept the last 2 digits and that's it.
Yeah.
Okay, all right. One last question in this problem. So using this 2, 3, 5, 6, and 9, I can form 5 factorial numbers, right? 120 numbers. All of us know, right? 5 factorial. Now,
30.
sorry?
Could you repeat how you got 36 as the answer one more time?
Oh,
Sorry.
sure. Okay, so did you understand that the last digit has to be either 2 or 6?
I
That part was
understand
okay.
up till the number 80 and then I didn't understand.
Okay, whatever I did, we did for the last digit being 2. Exactly same thing repeats for the last digit being 6. Because the last digit is 6, the previous digit must again be either 3, 5, or 9.
Yeah, so that's 3 factorial into 3, which is equal to 6 into 3, which is 18. Understood, Sundar.
Yeah, 80 and 18 and 18. So a couple of 18s, right?
Yeah.
And therefore 36.
Sorry.
Yeah, 18 plus 18. Yeah, 18 into 2. Okay, so one last question in this one. So using 2, 3, 5, 6, and 9, we all know there are 5 factorial numbers that can be formed, which is 120 numbers. What will the sum of these 120 numbers be?
Can you repeat the question?
What will the sum of all the numbers that can be formed using each of these 5 digits once? We know there are 120 numbers possible. If you add all of them, what will they get?
So 3000.
3,000. That seems
25
even.
into 120.
Okay, hold on. Before we go forward,
Sorry.
let's make sure. So one of the numbers is 23695, for example. This number itself is 23,695. How can the sum of the numbers be 3,000? I
Oh,
want,
no,
so it's
no.
going to be a huge number.
I misunderstood.
800.
I misunderstood.
Okay,
Oh, so some of the numbers or some of the digits?
sum of the numbers, not some of the digits. Some of the digits, so You can add it once
Yeah.
and multiply by 120, right?
So
Not the
could I-
sum of the digits.
Laptop charger, sorry.
Sorry, say that again.
Could I get my laptop charger?
Yeah. Okay, please. Okay, go ahead. Okay, everyone is clear, right? I'm not asking sum of the digits of these 120 numbers. If that were the case, then it's fairly easy, right? So 2 plus 3 plus 6 plus 9 plus 5, jo bhi ho. How much is this? 25, I think. 5, 11, 25.
Yes, that's
And
what
then we multiply
yeah.
25 with
20 in 120.
120 numbers. Probably that's what Arnav answered as 3000. I want the actual sum of these big numbers. So obviously the sum will be huge, but you can cleverly find out what the sum is without too much sweat. Okay. All right. So any idea, guys, how to proceed? Even if you don't have an answer, any idea
Yes,
on
sir,
how
I
we can
have an
proceed?
idea. I think I have.
Yeah, go ahead, Prashast. Yeah.
Okay, sir. So what I did was, so I decided to like tackle each of the numbers individually. I don't know how to explain it, but so like for example, so so there are, so let's take the first place, like where number 2 is currently. So like let's take that. So there
Okay.
are 5 ways it can be like that, correct?
Yeah.
Like there
Okay.
are 5 possibilities over there.
Okay.
So since there are 5 possibilities over there, so first let's tackle 2 itself. So then every like how many numbers does 2 change? So every 12. So if we arrange them in ascending order, so the first number, second number, all the way till the 12th number, 2 will be there. Then it'll be I think. So
All the
that
way till
will
24th number. There are total of 120 numbers, right? So 1/5 of them.
yeah.
So 24 numbers will start in 2.
Something like that. And similarly for the rest of them. I'm not sure if it'll work, but I think that is how I would go about it.
Okay. All right. Heard you. Nitya, you had some idea?
It's kind of basically like Prashast one. So my thing is like, see, we know that the sum of all the numbers is 25, right? So sorry, 25, right? So basically what I've done is, for example, rather than I've used the same idea but clubbed it together. So that for the first number, which is in the 10,000s place, there would be so many options, right? Well, no, I'm not explaining this well. Can I just get the answer and give it to you, and then
Okay.
we'll see
Fine.
what's
I
Yeah.
did it with Nitya's idea only.
Okay. Can you expand a little better, Ashi, if you can?
So we know there are 5 factorial ways, right? So now it'll do the sum of the digits will be 25. So then we multiply 3000 bracket 25 into 120. Then you'll expand on it, you'll get the answer.
Not entirely clear. So 25 is clear, and after that I was not clear what you.
So then you realize there are 120 ways to do it. So you do 25 into 120 and then into 3000 digits.
Why 25 into 120 itself is 3000. So 25 into 120 is 3000.
Yes,
And then
yes.
further by another 3000, is it?
Yes. No, sir, not like that. 1 second. You need to-
Sir, I
Okay,
got
Sukrit, go ahead.
117776.
117766 is a sum. Okay, all right. Okay, Sukrit, go ahead. What did you do?
Sir, so first in the 10,000s place, there's 5 possibilities. So I did 20,000 plus 30,000 plus 50,000 plus 60,000 plus 90,000. And then I added that divided by 10 and then divide by 10 plus divide by 10 plus divide by 10.
20,000 plus 30,000. Okay. So how many numbers with 20,000? There'll be 24 numbers with 20,000, right? Okay.
So
Okay.
can I speak once?
Go ahead, Arsh.
Like if if I continue on Sukrit's idea, I can do like yeah, what he said. So like 90,000 plus 60,000 plus 50,000 plus 30,000 plus 20,000, and then I add the I do 9,000 plus 6,000 plus 5,000 plus 3,000 plus 2,000. Then I do plus 900 plus 600 plus 500 plus 300 plus 200 till the units place. Like units place will be 25, and then like that, and then like get the total sum of the number.
Okay, all right. All of you have the right idea, but I somehow feel something is I could be.
I got it. I understood what I did.
All right, sounds good, Ashi. Okay, so let me just go through it once. So let's all of us have the same idea. Maybe there's a small mistake in multiplication. I'm not sure. Okay, so and I've not worked out the answer myself. Okay, so let's take some random digit for people who didn't follow the discussion so far. Let's say I'm picking some random digit here, right? So we all agree there are 120 numbers. Now, by equal split, 24 numbers. So if I'm looking at this digit, the tens digit, 24 of those numbers will be 2, 24 of those numbers will be 3, and so on. 24 of the numbers will be 9. Okay, so if I add, including the place value for this is 10. So the place value for this is 10. And whatever I do, I'll repeat the same thing. For here the place value is 10,000, 1,000, 100, and 1. Right? So 10 for this particular example, this particular place. Now, there are 24 numbers that start in 2, 24 numbers that start in 3, and not start. 24 numbers which have a tens place of 2, 24 numbers which have a tens place of 3, and so on. So all of those numbers will add up to 24 into 2 plus 3 plus 5 plus 6 plus 9. Okay, so this will be the sum of the tens digit of all of the numbers that we discussed. Now the same thing has to be applied. Now why should I do with just for the tens digit? Whatever I apply exactly same thing for each of those digits. So this is the tens digit. Do the same thing for the hundreds digit. Do the same thing for thousands digit, and do the same thing for the 10,000s digit. Right? So it's 10,000, or rather 11,111 into 24 into this sum, which is 25. So clearly the number will end in 0. So this is 3. This is, we worked it out, right? 24 into 25 was how much? 600. So this was 600. Right? So and then this is just 6666600.
Can you explain?
So can you repeat once more?
Okay, I'll repeat once more. I'll repeat once more from the very beginning. Okay, so I'll erase all of this and hope I didn't do silly
Then
mistake.
after that, can you state like why my?
Sure. Okay, we'll discuss that also. Okay, so I'm taking just one example, which is the tens digit. There are 120 numbers. Now by equal distribution, 24 of these numbers will have 2 in the tens digit, 24 of the numbers will have 3, 24 of numbers will have 5, and so on. 24 numbers 6, 24 numbers will have 9 by equal distribution. So if I just focus on the tens digit alone, the tens digit itself has a place value of 10. Now, what is the sum of all the numbers? 24 times 2 plus 24 times 3 plus 24 times 5 plus 24 times and so on, right? So that sum is this. So what is this? This is 24 into 25, right, into 10, or rather 10 into 600. So the sum was 600, and then the place itself had a value of 10, and therefore 600 into 10. Now, whatever I do, I repeat the same thing for the units digit, the hundreds digit, the thousands digit, and the 10,000s digit. And each digit is going to go through the same thing, right? If I just focus on that digit alone, it's going to be the same sum. And therefore, the answer is this. So this adds up to 111111. 10 times 6 is 666, 66600. Ranbir, is this clear to you, this method?
Yeah.
Okay. Arsh, if you can repeat your method clearly, if you still want to,
Yes,
we
sir.
can find the mistake in what you did.
So like if I take 9s in the 10,000s digit,
Okay, so you want to focus on 10,000 digit. Okay, all right.
90,000, and then if we do that with each digit over there, it'll become 60,000, 50,000, 30,000, and 20,000.
Correct.
We add the sum.
Correct.
And
And how many 90,000s there are? There are 24 numbers which have 90,000s. Not just one number. There are 24 of them, right?
Oh, right.
Right? So you're missing a factor of 24.
Yeah.
Yeah.
Okay. Got it.
Now the same
So
problem.
why did we?
Go ahead.
No, why did we add 2, 3, 5, 6, 9?
Because
Why
so
add?
because 24 of those numbers will have 2 in that place. 24 of those numbers will have 3 in that place. So if I have to add, if I have to add all of those numbers, I mean, what do you mean? Why do we have to add? I mean, we have to add because the question is to add, right? I'm not clear on what your
Wasn't it the
doubt is.
product of all?
No. The question was find the sum of all of those.
Oh.
Yeah.
So I thought it was the product of all. That's why I got confused.
Oh, no, not the product of all these 120 numbers. That becomes crazy, right? So maybe that can be a different problem altogether, but no, in this case, it was just the sum. Okay, all right, let's move on. That was question 4, variant question 5. 16 trees are laid out, equally spaced. The distance from the first tree to the 5th tree is 80 feet. What's the distance between the first and the last tree? Okay, so between the first and the 5th tree, there are 4 gaps, right? So 4 gaps correspond to 80 feet, right? Therefore, one gap is nothing but 20 feet. Now, what is the distance in feet between the first and the last tree? So there are a total of 16 trees. Therefore, there are 15 gaps. So 15 into 20, which is 300. Okay, so fairly straightforward. A small additional question on this one. Now, these 16 trees are placed like this, right? So I'll just write it out. So this is the first. Okay, it's more like a man, not a tree. Fine. All right, I'll draw a tree. Okay, so this is one tree, this is another tree, this is another tree, and so on to there are 16 trees. Okay, now what you do is you are at the first tree. This is the first tree, and this is the 16th tree, mind you. Okay, now you walk, touch the second tree, and then come back. And then you walk, touch the third tree, and then come back. Touch the 4th tree, and then come back. You do the same thing till you touch the 16th tree and come back. Okay, what is the total distance you cover? Can you guys work it out?
So can you repeat your question?
I'm not repeating a question. Why should I repeat, Arsh? It is fairly straightforward, right? What was not clear?
So my voice, I don't know. I even switched off my camera like mentioned.
Oh, okay. That way. Okay. All right. Can anyone else repeat the question? Sukrit, can you repeat the question for Arsh?
Okay, so there are 16 trees and you walk from the first one to the second one and back, then first to third and back, and you keep doing that till 16. What's the distance you'll cover?
Oh,
Exactly. From the first tree, you walk to a certain tree and then come back. And then you do that all the way. So you'll walk quite some distance. How much is the distance?
Sir, I got 240.
240. Okay. 240 feet. Okay.
And so just confirming the distance between the trees is the same in the question, right?
Yeah. Everything else
Sir,
is same as in
Sir,
the
it's
question.
2,400 feet.
2,400 feet. Maybe it's a scale factor. Precious, I'm not able to see you.
Sir,
Maybe
I'm
your camera
getting-
is way up. Yeah.
I'm getting 2,400.
2,400 as well.
Seven, I'm getting 2004.
Okay. All right. So let's say let me just count the number of gaps. So you first go and then come back. So a total of 2 gaps you cover. And then you go and then
No,
come
no,
back.
Sir, excuse me, sir.
So I'm getting
Sir, it's
5,000.
actually 4,800.
So I'm getting 5,400.
I think 4,800.
4,800, 5,400. Any other
Sir,
answers?
5,440.
5,440.
Yes, sir.
Okay.
10,080.
7080.
No, 10,080.
Sir, I got
10,000.
252 feet.
That seems too small, no? 252 feet. Okay, all right.
Hmm.
Okay, so let's discuss, guys. We have had a few answers,
Oh,
right?
so 80 feet from each. Oh,
I haven't changed rest of the question, right? What the
One
rest of the
second.
question details are exactly same. Okay,
So I
let's
got 4,780 feet.
So then my
4,700.
answer is
Right, sir.
252 and 220.
Okay, so do that
Sir,
and tell me how
my
much is this?
answer is I thought the distance between one was 1 feet.
So minus 5040 feet.
5040 feet. Okay, all right. So people, some have forgotten. Sukrita, I heard what you said.
Sir,
I don't know why you have to make that assumption because, like I said, right, everything else remains the same. Okay, but let's discuss.
Sir, I have
Right.
an answer. Should I say it or?
Go ahead. One last answer, and
Yes,
then
sir. So it's 54,400.
54,400.
sir, again.
Go ahead, Sukrita.
Sir, I got 4280 feet.
Okay, all right. I'll stop taking answers for now. Let's
99,680.
99,680. Okay, let's stop the answers here, guys. No, please. Let's stop. Let's discuss. Okay.
10,99,000.
Okay. What is that, Vanya? I didn't hear that. Well, it's okay. It's okay, Vanya. It's okay. It's fine. So many answers. Maybe I got it wrong. Whatever. Okay, let's count the number of gaps. So up, down, and then you go, and then you go, and then come back. So 2 gaps, 6 gaps all the way till the last one. From 1 to 16 is 15 gaps, and then coming back is another 15. So 2 plus 4 plus 6, so on till 30. So many gaps, and then we'll multiply later by the gaps. So what is this? This is 2 into 1 plus 2 plus 3, so on till 15 gaps again, right? So how much is this number? So 1 plus 2, so on till 15 is 15 into the next number, divide by 2. Okay, so many gaps, but each gap we discussed in the first step itself, the gap is 20 feet, right? Between the first and fifth is 80 feet. That means each gap is 20 feet. So this whole number into 20 should be the total distance traveled. So this gets cancelled. 16 times 15 is, how much is this? 240, I guess, right?
240.
So 240 into 20 is 4800. Okay, so fairly straightforward, but I don't know why I can see some other scaling mistakes like 2400 or 242. All this I can at least understand. You missed a 2 or a missed a 10 and all that, but I don't understand these other numbers like 5400, 10,080 and all that. Okay,
Then
anyway,
I added it till 2 to 32 instead of 30.
Sir, I
Okay.
went to 16 and I did 16 gaps instead of 15. So I did 17 into 15 instead
So
of.
even I did the same thing.
I did the same thing and then I multiplied it by 2.
Into 8, right?
Yeah.
Okay, all right. So different ways of making mistakes. That's good. Okay, let's move on. So that was the tree question. Question 6. James has 20% more money than Yao. Bob has 20% less money than James. What percent? So there are 3 people, right? James, Yao, then Bob, right? Okay, so we can start somewhere, doesn't matter. I'll start with James has 20% more money than Yao. So I'll just say Yao is 100. Okay, so James therefore has to be 120, 20% more. Now Bob has 20% less money than James. So Bob has 20% of 120 is how much? Is 24. So 24 less than James, right? Than 120, which implies this is 96. So Bob has 96. What percent less money does Bob have than Yob? So it's 196 comparison, which is 4%. Okay, so fairly straightforward. This reminds of another like standard problem. Let's say I sell 2 articles. I sell 2 articles for okay, $138 each. Okay, $138 each. Okay, on one, I'm making 20% profit. And then on the second one, I'm making 20% loss. Okay, I sold both of them for the same, right? One was a cheaper one that I sold for 138. One was an expensive one I sold for 138. So I made profit on one and I made a loss on another. What is the overall percentage profit or loss?
Sir, I
Okay,
know
no-
this
no-
answer
no-
because this was in our math textbook last year, like 30 times.
Okay, wonderful. You can call out your answer and no calculator, guys.
So should I call it out?
Call out your answer, Arnav.
I think it was 5% according to my memory.
5%. Okay, you remember so much that it's 20%. I mean, I'm just randomly
No,
made up
because
this
this
number.
question, I don't actually remember the answer. I'm not sure if I'm correct or no, but this question was so repetitive,
Yeah, that's a very famous question, right?
that
And
after a while you
and the
got
number
used to it.
138 is irrelevant. I intentionally gave some
What
numbers
did
so
we-
that people get
Zero.
lost in calculations. Huh?
So what did be like? Just like the total profit or loss. What did be 0?
Okay, 0% is Precious's guess. Arnav, you said 5% profit ki 5%
One
loss?
sister just
5% profit or loss, Arnav?
Loss.
Loss. Okay.
Sir, minus sir 4%.
2%
Loss.
loss or profit? Loss. Okay. Any other answers? Sorry?
No, 4 only.
She is also getting 4. Okay.
Sir, even
Anjana, you said you also got what?
4.
4. Okay. All right. So let's discuss. It's a fairly a straightforward question and a popular question. So you should know how to do this. So the number 138 really doesn't matter. So I'll just go with standard cost price and selling price, right? Now, on one, he made 20% loss. So let's say he sold both of them for X, right? So this is X. Okay. So this is also X. So the cost here should have been X upon. So this is the one where he made profit, right? X upon 1.2. Because just think about it. If the cost was X upon 1.2 and he made 20% profit, then after multiplying by 1.2, he got this X, right? So after making 20% profit, he got this X. Similarly, if he made a loss on this one, the price should have been X upon 0.8, such that when you multiply this by 80%, you get back your X because you were able to make only 80% of the cost price, right? Therefore, when you multiply by 80%, you're getting back X, which means the cost price was X upon 1.8. Okay, so in other words, the total selling price was 2X and the total cost price was the sum of these two fractions, X upon 1.2 plus X upon 1.8. Now let's add 1.2 and let's add these two fractions. So maybe if it's easy, you can keep 10x plus 10x upon 12 plus 10x upon 8 if it's easier for you to deal with it. Okay, so the common denominator for 12 and 8 is 48 or 24 rather, 24. So 10x times 2 and then 3 here, right? So 2 plus 3, which is 50x upon 24. So his total cost price was slightly more than 2x, right? 50x by 24 is slightly more than 2x. And Precious, therefore, he'll be making a loss, not 0% profit. And the total selling price is 2x, which is slightly less, therefore the loss. So how much is this loss? Is just, let's find out what the fraction is, right? So 2 as a fraction of 50 by 24. So his selling price was 48 by 50 fraction, or rather 96 by 100 fraction, right? His selling price was 96% of his cost price. And therefore he made a loss of 4%.
And sir, one more thing, sir. I understand your way and it makes perfect sense, but so the way I did it, sir, it's also making sense.
Go ahead, please. What is your way?
Yeah, so like let's forget 138. Let's say he had 100. Okay,
Okay. Yeah, I didn't even deal with 138 anywhere here. I gave him the
so
problem.
then
Okay.
just like go a little up.
Okay. All right.
Yes, so he made 20% profit, 20% loss. So 20% profit, which means he got 120 on one, and he got 20% loss on one, which means he got 80 on one. So then,
But the problem is you're assuming the cost prices are same. Actually, that's not the case. The selling prices are the same. The cost prices are different. The starting point is the selling price. So what you say is if two cost prices are same, if I make 20% profit on one and 20% loss on the other, then the total profit or loss will be 0. But if the two selling prices are different, if I'm making 20% profit in one and 20% loss in the other, then the two cost prices will add up to higher than the two selling prices. And therefore, you'll always incur a loss.
so I don't get it.
No. So this is like saying, okay, all right. So this is like say what you are saying is cost price was 100. In one scenario, the selling price was 120. Cost price was 100. In the scenario, the loss of 80. And therefore, total was neither profit nor loss. This is what you assumed. But that's not what I'm saying. I'm saying the column's selling price is the same, which is 100 and 100. And we back out the cost price and we back out the cost price here. And the cost price that's backed out here is 100 upon 1.2 and 100 upon 0.8. And these two numbers do not add up to 200. They add up to more than 200.
Sir, I still don't understand.
Okay, think about it. I mean, you just have to form a simple grid of cost price and selling price, and which direction you need to multiply by 20%. Yeah, it's always the base is cost price, right? With cost price as the base, you work out the selling price always. Yeah, Arnav, you had a question?
Sure, I can explain to him in another way if he likes.
Oh, okay. Hold on 1 second, Arnav. Anjana, what was your question?
Yeah, I didn't have a question. I just wanted to explain to Precious to her.
Okay, all right. So both of you are anxious. Okay, fine. Anjana, I'll let you do the honors. Yeah, can you explain once?
So basically, what Sir was saying is that you thought of it in a way where the cost price is the same. So say you buy 2 magazines. The magazines are the same price. You got one for 100, the other one also for 100. But when you sold it, you sold the first one for more money and the second one for less money. Did you understand till there?
Yeah, kind of.
So like in a general question, like a standard question, you'll get cost price is the same, selling price is different. So you're selling it for 120 and the other one you're selling for 80 rupees, right?
Oh, okay, got it.
But then the sum that we are working on, it's the cost price is different, but the selling price is the same. So you buy a magazine for 100 upon 1.2 and one is 100 upon 0.8. But the selling price is the same. So you still make a loss.
Okay, yeah, got it.
Yeah, and the more or less that she's talking about, those quantities are not the same. So it does not compensate exactly. So hence we get a difference, right? So obviously in one case it's more and one case it's less, as she was saying, right? But this more and less, those specific quantities are themselves different, and therefore they do not compensate for each other. Okay, work it out again, Precious. I'm sure you'll see it. Okay, cool. So yeah, Arnav, back to what you were saying. So the standard trick for that is, if it's X%, so instead of 20%, suppose it's 30%, the answer would be 9% loss. So here it's 4% loss. So the way you work it out quickly is, what is if it's 40%, that is 16%, right? Loss. So it's like a square behavior.
2 square is 4, 3 square is 9, 4 square is 16.
Exactly. So 20% square, if you do 20 into 20, 400 upon, so 20% into 20%. So if you do 20% into 20%, what do we get? We get 20 by 100 into 20 by 100, right? So that's 4% effectively. So similarly, if it's R% profit and R% loss, in two different scenarios, the total loss will be R square %. So if you make 40% profit and 40% loss, and then it'll be a 16% loss. Okay. Cool. Next one. All right. We have still not come to some of the harder questions. We are still doing more versions of the easier questions. Okay. What is the distance in this case of AB? Sorry, it didn't paste well.
So I think Prashant has a question.
Yeah, just 1 second.
Not a question and answer
For which one?
for this one only.
Yeah, no, that's fine. I'm not discussing answers, like as in I'm not going around and asking answers. I'm just asking some harder questions of this original one, right? So the original question, I'm just discussing myself here, right? So this is 7. So this is 7 and this is 17, right? This gap is 17. Okay, and this gap is 10 here. So now the distance AB is like a triplet using 10, 24. So that's the 5, 12 family, right? You don't have to waste time doing 10 square plus 24 square and all that. You just realize that this is a scaled version of 5, 12, and 13. Therefore, this is 26. Okay, so fairly straightforward. I'm just thinking any other variant possible in this case. Not much, right? Okay. Question 8. What is the probability that a randomly selected positive factor of 72 is less than 11? Okay. So how many factors does 72 have? You can just list it out
So
quickly.
12.
Yeah. So we can either do the prime factorization. So 8 and 9, and this is 2 cubed, and this is 3 square. So there's 4 into 3, which is 12 factors. 12 factors. Now, what is the probability that randomly selected is less than 11? So what are the factors which are less than 11, including 1, 2, 3, 4, 6, 8, 9. I think that's it.
It's 7 by 12. So
Okay. 1, 2, 3, 4, 5, 6, 7. So 7 by 12 indeed. Okay. Question 9. I'm just glancing through to see if there's any difficult question I can make. If I do, then I can. Okay, there are 120 different numbers. We are arranging 1, 2, 3, 4, 5 in all possibilities. If these numbers are in place in numerical order, what is the 73rd number? Okay, so clearly there are 24 numbers that start with each of these digits, as we just saw in another problem. So first 24 will finish starting in 1. Second 24 will finish starting in 2. 72 numbers would have exhausted by the time we finish the 3 series. Now the 73rd number will be the very first number in the 4 series. So I'll start with 4, and the smallest number starting from 4 should be the answer, right? So it's 4. What is the smallest number starting from 4? 1, 2, 3, 5. So 4, 1, 2, 3, 5. Okay.
So I didn't understand this one.
Okay. Do you understand that from each number, you get each starting number, you get 24 numbers? That you understand?
Understood.
Okay. So starting from 1, there are 24 numbers. Starting from 2, there are 24. Starting from 3, there are 24. So you exhausted 72 numbers by the time you finish the 3 series. Now the 4 series is just starting, and we want the very first number.
So 4, 1, 2, 3, 5. Understood.
4, 1,
Yeah,
2, 3,
because it's the smallest smallest 5-digit number starting with 4.
Right. All right. So let me just ask another question on this one. What is the 73rd number in the list counting from the back? Okay. So 73rd number in the list from the back. Can all of you work it out?
can I answer?
So
Can I
can
answer?
I have the answer?
It'll be 2, 5, 4, 3, 1.
Only one attempt, then you cannot go back. If you guys are okay with that, since I'm giving multiple options for everyone, you guys are just reckless. One attempt, and okay, Gyan, go ahead. If you have one attempt, you're confident.
2,
If you're not confident,
5,
then
4,
wait.
3, 1.
Sorry, say that again, Gyan.
No, so I'm confident.
Go ahead.
25431.
25431.
I agree with him. 25431.
Even I agree.
Yes, sir. I agree.
Agreed.
Okay.
I agree.
All right. So let's discuss, right? So there are 24, 24, 24, 24, 24. I'm counting from the back, right? So this 24, and this 24 get exhausted. All right. So this is starting from the 1 series. This is starting from the 2 series, 3 series, 4 series, 5 series. I want the 73rd number, which means I want the largest number starting from 2. So starting from 2, the largest number is indeed 25431. Yeah, well done, Gyan. And whoever else responded soon after that. Okay, cool. Again, we can ask this number to form any number, right? In fact, I could ask, what is the 97th number? You guys know how to work it out, right? You just count in 24, and then you finish 7. So not 97, maybe 89th number. So you finish 72, and then the remaining 17, again, you can group in smaller groups, right? There are 6 numbers, 24. Sorry. In fact, let's all do it, guys. Can you find the 89th number from the front? Find the 89th number from the front. 89th number. Okay. For this question.
From the front meaning ascending order, right?
In whatever ascending or placed in numerical order. Numerical order is ascending order. Ascending order, yeah. 89th number in ascending order.
So
Yes, go ahead, please.
43512.
43512. Jan.
I'm
Okay.
putting the same, sir. 43512. Same.
Okay. Same. Okay. I'll give another 15 seconds for people to finish up. Confirm.
So the same one as Gyan.
Same. Okay.
Same.
All right. So 24, 24, 24. So 72 are exhausted. Now we are in the fourth 24. The fourth 24 series begins in 4. So this, right? They begin in 4. The first digit is clear. Now, of these 24 numbers, right? So now if I focus on this digit, 1/4 of them will start with 1, 1/4 of them will start with 2, 1/4 will start with 3, 1/4 will start with 5. So I want the 17th number, right? I have exhausted 72. Counting from 73 onwards, I want the 17th number, right? So I know that there are 6 numbers from each starting point, right? So starting from 1, there'll be 6 numbers. Starting from 2, there'll be 6 numbers. Now, starting from 3, there'll be 6 numbers, right? Of the numbers starting in 3, I want the 5th number, right? Because I've exhausted 6 numbers here, I've exhausted 6 numbers here. I need to go to the 17th number. So I need the penultimate number starting from 3. So the penultimate number starting from, the ultimate number starting from 3 would be 5, 2, 1, right? If I put in descending order, it's 5, 2, 1, but I want the one just before that. So the penultimate number would be 5, 1, 2. Yeah. Make sense?
Yes,
5, 2,
sir.
1. Yeah. Okay. Cool. Yeah. Well done, guys. Again.
Sir?
Yeah.
So I got confused. Why not 521?
Because 5, 2, 1 will be the 18th number and therefore the 90th number. 5, 2, 1 will be the last number starting with 4, 3. Are you with me, Neve?
Yes, sir. Yeah.
Yeah. Is everyone clear?
So can you repeat once more?
I'll repeat once more. Okay, okay, so we need the 89th number. So first level of bucketing, 24, 24, 24, 24, 24. So we have exhausted 3 buckets of 24. So we are in numbers starting with 4. Now, in the numbers starting in 4, there are 24 numbers starting in 4. Now my focus shifts to the second digit, right? So 6 digit. So starting with 4, the first 6 numbers will start with 1. The second 6 numbers will start with 2. The third set of 6 numbers will start in 3. And the last set of 6 numbers will start in 5. Now, I want the 17. So let me just exhaust 1s and 2s. Now I'm in the 3 series. In the 4 3 series, there are 6 numbers. And I want the 5th of them. From there, you can figure out, right? The last one is 521, and therefore the one before that is 512. Okay. All right. So that is question 9. Question 10 is simple trapezium area, right? So finding the area of a trapezium. Points A, B, C, D have these coordinates. Area of the quadrilateral A, B, C, D has even drawn the diagram for us. So making it very, very easy for us. So we just have to apply, right? A is 3, 5. This is 3, 5. 3, minus 5.
Question.
So this gap is 10. Just hold on 1 second, please. This is 10. This is minus 3, 2. And this is minus 3, minus 5. So this gap is 7. Okay. And now this gap is how much? 3 and minus 3. The gap is 6. So area of a trapezium is your distance between the 2 parallel sides times the average of the 2 base lengths. So 7 and 10 ka average. So 17 into 3, which is 51. Okay, fairly straightforward. Yeah, Precious, go ahead. Go ahead, Precious.
So how did we get CB as 6?
CB as 6 because one was 3, minus 5. Other one was minus 3, minus 5.
Oh, so that's minus 5. Okay.
Yeah, 3.
Excuse me, sir.
Yeah, maybe my handwriting was really horrible, but you can look from here and here.
Excuse me, sir.
Yeah, Jan, before I go to you, let me go in ascending in the specific order. Precious, you had a doubt first.
Yes, sir. I'm just saying. So isn't the shoelace formula similar, easier to use in all of these instead of like remembering the formula for each quadrilateral or whatever?
You can use the shoelace also in this case. In this case, it's just a simple trapezium, which is why I did this. You could use shoelace and get the same answer. You get the same answer using shoelace.
Yes, I did, because like at that moment I wasn't able to recall the formula. So just like I was like quickly, chalo, I'll use shoelace.
Yeah. That's perfect. Yeah. Vanya, you had a question also, I thought, in between.
No, sir, I asked it.
Oh, the 3 and minus 3. Okay. All right. Gyan, what was your question?
Sir, it was about the shoelace formula only.
You want me to recap the shoelace?
Yes, sir, once on this.
I'll do it for everyone.
And
Anjana,
so
what is your question?
What's the derivation for it? Like, where did it come from?
You can look it up on Google. I don't remember the derivation offhand, and let's not waste the class time on the derivation. Anjana, yeah.
Sorry, so I didn't really understand the 6 into 7 plus 10 upon 2. I understood everything except that.
If I have a trapezium, conceptually, what is the area of a trapezium? I have 2 parallel sides and 2.
I understood all of that. I understood all of the numbers. I just didn't understand the formula again.
The formula is the height, or rather the distance between the 2 parallel sides times the length of the 2 parallel sides ka average.
Oh, okay.
That's the formula for an area of a trapezium.
Yeah, okay.
Okay, now back to what Precious was saying, and we can use a shoelace for any random quadrilateral. Even if it's a square, for example, you could use shoelace, right? But shoelace is more general. If you don't have a pattern, you don't want to think too much. Let me just recap shoelace again. Write it in cyclic order or anti-cyclic order, doesn't matter. So I'll just go in the same order. 3, 5, 3 minus 5, minus 3 minus 5, and minus 3, 2. And then I'll write back the very first number, which is 3, 5 again. Okay. Now, the reason it's called shoelaces, you go in one direction, this. Okay. And then go in the opposite direction. First, let's go in this direction and multiply all of these products. So I have minus 15, again 3 times, again minus 15, and then minus 6, and then again minus 15. So this sum is adding up to minus 51. Okay, so that's one sum. Now let me go in opposite direction. this is 15, this is also 15, this is also 15, and this is 6. So just hope it happens to be all the numbers are positive equivalents of them. Therefore, they add up to 51 in this case. And the final shoelace method says it's the difference between these two numbers. Again, just pure coincidence, these numbers are matching exactly with the signage difference. But in general, the difference between the two, which means the bigger one minus the smaller one, divided by 2. So it's 51 minus 51 whole divided by 2, which is 51, which is the same answer that we got here. Okay. Let's see whether another is a question possible here. Okay, fine. Question 11. Okay, all right. So we wanted to do a class for till 4:45. So maybe it's a good point to break for 5 minutes, right? 5 to 7 minutes. So let's regroup again at 45, right? It's right now 3:37 on my clock. 3:45 will convene again. Okay, and then we'll go on for another hour or slightly more possibly. So 3:45 guys, if you can be back. Okay, all right. Just finish your restroom break or water break, whatever.
Thank you, sir.
Okay. Right, hope everyone is back or they'll be back in another few seconds. We were in question the 10, the trapezium wala question. The one after that is this. Okay, of 60 students in a class, 14 prefer blah, 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 18 prefer blah, 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 8 prefer blah, blah, blah. Half of the remaining, okay, so how many have we exhausted so far? 14 plus 18 is 32. Let me just make sure I'm recording is on, right? Recording is on. Yeah, okay. So 14 plus 18, 32 plus 8 is 40 are already over. Now, of the remaining 20, half of them cherry pie, which is 10, and remaining half is lemon, which is the remaining 10. Now, this guy is trying to show it in a pie graph, how many angles for cherry pie. So 10 is what fraction of 60 in a 360 degree. That's what a pie chart is, right? 360 degree. So 1/6 of that, which is 60 degree. Okay. Straightforward. I couldn't think of other variant. So probably one other variant might be, what is the difference in the angle between a chocolate pie and an apple, right? So difference is 18 minus 14 is 4. So again, 4 out of 60 is what angle that it corresponds to. Something like that. It could be another question. Okay, next is just permutation combination. So this guy is eating something. Okay, how many different meals can he choose? Yeah, so straightforward, right? How many
1,000.
different possibilities there are in each of them? So 5 in this case, and then 1, 2, 3, 4, 5, 6 in this case, and then 1, 2, 3, 4, 5 in this case, right? Unless I'm doing something wrong. So
No,
5
sir.
and yeah, how much is this? 150, is it? Why don't I see an answer like that? 150 here. 1,
Because
2, 3.
sir, it said that he can only choose a certain amount of items for each like.
So
Oh,
it's
let me read the question. He chooses 2 different kinds, or 3 different vegetables and 4 different desserts. Sorry, I didn't read the question at all clearly. Yeah, so of the 5 here, so he has to choose 2 of them. So 5 choose 2 ways. Of the 6 vegetables, 1, 2, 3, 4, 5, 6, he has to choose 3 vegetables. And then he has to choose 4 desserts of 1, 2, 3, 4, 5. So 5 choose 4. So it's the product of these. So this is just numbers, right? 5 choose 2 is 10. 10 choose 6 choose 3 should be 6 into 5 into 4 by 6, which is 20. And then 5 choose 4 is 5. So it's 1,000.
Sir, I didn't understand. Could you repeat the
Okay.
61?
You understood it's 5 choose 2 into 6 choose 3 into 5 choose 4?
Yes.
And rest is just finding out the numerical value for each of them. What is 5 choose 2? 5 factorial by 3 factorial into 2 factorial, correct?
Right.
So it's 5 into 4 by 2 into 1. The 3 factorial gets knocked off. Likewise, 6 choose 3, 6 factorial by 3 factorial into 3 factorial. So 6 into 5 into 4 by 3 into 2 into 1, which is just 20.
Understood.
And so on. 5 choose 4 is same as 5 choose 1. Right? Of 5, you have to choose 4, means you effectively same as choosing 1. Because that's what you're going to reject.
Understood, sir. Thank you.
Okay, no problem. Let me ask one other question in this one. Okay. He can make a meal by choosing one or more of each of these 3 categories, right? So in this case, he chooses 2 of this, 3 of this, and 4 of this, right? So I'm saying he can choose a meal by choosing one or more of each of these categories. How many different meal possibilities are there? Is the question clear to everyone? Arsh, is the question clear?
So like he has to choose one at least from what?
For each category. From each category, he has to select at least one.
Yeah.
So he can choose one or more from each category. How many different meals are possible in that case?
So he has to choose at least one, but he can take how many of them, right?
Correct. He can choose 3, he can choose 4. From each category, he has to select at least one. How many different meals are possible?
The order doesn't matter.
Order doesn't matter. So, in other words, okay. So what I'm asking is fairly obvious numerically, right? So I'm asking 5 choose 1 plus 5 choose 2 plus 5 choose 3 all the way till 5 choose 5 times 6 choose 1 plus 6 choose 2 all the way till 6 choose 6 times 5 choose 1 plus 5 choose 2 all the way till 5 choose 5, which is going to be huge, right? Okay, but conceptually, we understand that this is the number that we want. Is everyone clear that this is the product that we want? Now, how we can work it out more efficiently, that I'll come to in the next step. But do we all agree that this is what we have to, Arshi, do you agree this is what we have to work it out? Okay. Rachit, are you there with me as well? Understood? Ranveer, you agree that this is the expression that we want. Now, how can we take any of these? For example, what do you think will be 6 choose 1 plus 6 choose 2 all the way till 6 choose 6? Can you guys work it out and see what number you get? Just do with the 6 and then you'll see whether you're able to recognize that number. 6 choose 1 plus 6 choose 2 all the way till 6 choose 6. What is that number?
Sir, I think I could be wrong, but 64?
64. You are slightly wrong. It is 63. So 6 choose 1 plus 6 choose 2 all the way till 6 choose 6 will be 63. And this number 63 is 1 less than 64. And the number 64 is 2 power 6. So sum of the binomial coefficients. In fact, if you add 6 choose 0, it will be exactly 2 power 6. But because I'm not adding 6 choose 0, it is 1 less because 6 choose 0 is 1. Okay. In fact, let me include 6 choose 0 also. So can you guys think why if I add 6 choose, forget about this problem, just focus on this question. So just on vegetables. So there are 6 vegetables: beans, corn, potato, tomato, broccoli, chives. Right? Now, why is that 6 choose 0 plus 6 choose 1 all the way till 6 choose 6 is 2 power 6? Anyone can give some intuition on this?
So can you repeat?
Okay. So numerically, we are able to see that 6 choose 0 plus 6 choose 1 all the way till 6 choose 6 adds up to 64, which happens to be 2 power 6. But it's not coincidence. There is a reason for why the sum of all of these will add up to this. Now, if you guys can think of some intuition on this one. If not, I'm going to give it to you, but 15 seconds, I want you to think. Yeah, Precious, go ahead.
I have a rough idea.
Fine.
So like how 6 choose 0 is equal to 6 choose 6. So both of them are the same. So we can just do 6 choose 0 into 2. Then we can do 61 into 2. So maybe that's one way we can think about it, I think.
Okay, but even assuming that's the case, like you're saying there are pairs. But why would the pairs add up to half of 2 power 6? Why should they add up to 32? And then you can double it to give 64. But that's a good observation. 6 choose 0 is symmetric to 6 choose 6. 6 choose 1 is same as 6 choose 5. All that is fine. But why do they add up to 2 power 6? Nitya, yeah.
See, that isn't 6 to something. It's basically 6 upon like that factorial, right? So then see, every time, the reason it's 2 to the power 6 is because A, every time when you're dividing it, the 3 gets cancelled out, correct? And then B, later, there are 2's also get cancelled out, but there are more 2's left over. So it ends up becoming 2 to the power 6.
Not very convincing, Nitya. You know it for yourself. But good try though. Okay, actually the intuition is very easy compared to what you guys are thinking, right? So what am I doing here, guys? Okay, so just imagine there's beans, corn, potato. Okay, forget baked, right? So beans, corn, potato, tomato, broccoli, chives. Now I want to make a meal out of vegetables, which means I'm just surveying. They're all spread out in a table. I go to each of them, either I include beans or not include beans. I include corn or not include corn. I include potato or not include potato. So as I pass through each of these items, I have a yes or a no choice to make. And therefore the answer is 2 power 6. Right? So bean, yes or no. Corn, yes or no. Potato, yes or no. Yes or no. Yes or no. Yes or no. So it's 2 power 6, which is 64. But then I cannot say no to everything because I must have at least one vegetable. Otherwise, mom will be unhappy. And therefore, I'll have to subtract 1 to make 63 to make sure there's at least one vegetable. Right? So the only answer that's forbidden is no, 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 no for the vegetables. There must be some yes. And therefore, 63 ways. Right? I can use the same analogy for the other 2 categories as well. Therefore, the answer is without working it out. So it's 2 power 5 minus 1 for the first category, 2 power 6 minus 1 for the second category. Similarly, how many are there? 1, 2, 3, 4, 5, right? Again, so 31 in this category. So the answer is 31 into 63 into 31. So it's again another painful multiplication, but at least much simpler than having to work out. So the main takeaway for you guys is, if I add all of these, so if I add 10 choose 0 plus 10 choose 1 plus 10 choose 2 all the way till 10 choose 10, you don't have to work it out. You know the answer is 2 power 10, which is 1024. And sometimes, depending on the question, you might not have 10 power 0. So you only have to add the remaining, which is 2023. And sometimes, like what Precious was saying, right? Suppose it's just 10 power 10 choose 0, 10 choose 1 all the way till 10 choose 5 alone, right? Then 2, 3, 4, 5. Then you can say this balance out of with 10 choose 10. This balances off with 10 choose 9 and so on. This balances off with 10 choose 6. Okay, now you have to be it's a little tricky here, right? There's nothing to balance 10 choose 5. 10 choose 5 is only one number instead of 2 numbers. But you can do some simple jugad and figure out for that extreme case, because you can apply these 2 are same, these 2 are same, these 2 are same, and so on. Okay. Let's move on. Next question. Question 14. Question 13. So this guy is peeling potatoes at some rate. After 5 minutes, someone else is joining him, right? So after 5 minutes, what has happened? He has already peeled 5 into 5. 25 potatoes is already peeled. So only 120 potatoes are left. And now Charles also joins Helen. And Helen is peeling at 5 per minute. Charles is able to peel 7 per minute. So together they're able to peel 12 per minute, right? So, and then over the next 10 minutes, they'll peel everything, of which the contribution from Charles would be 70, right? This 12 per minute is 7:5 ratio, right? Therefore, this guy is peeling 70, this guy is peeling 50. Of course, the question could have been also, how many did Helen peel in total? So in which case you should add the initial 25 that she peeled, therefore it became 75 for her. But that was not the question. The question is how many did Charles peel, which is just simply 70. Okay. But all of these rate wala questions, you guys know how to do it, right? So for example, let me just make up one question. So let's say A alone. Okay, so A alone can finish a task. A alone finishes a task in 3 hours. Okay. And B alone finishes the same task in 5 hours. Okay. If they work together and assume, right, if it's like working together as in it's like lifting a weight, right? More people there are, it's so much easier. It's not like a brain wala kaam where it's not necessarily additive. In fact, brain wala kaam, it might be disruptive if 2 people are working together, right? So if you work together, in how many hours can they finish? Let's say this is peeling oranges here, peeling oranges or peeling potatoes, whatever. So there are some number of potatoes. A alone can peel them all in 3 hours. B alone can peel them all in 5 hours. If they sit together and peel, in how many hours can they peel? Can you guys work it out? Sarab, can you mute yourself, beta? Yeah. And many people, cameras are off. Since it's one of the last classes, I'm not bothering too much. Neev, Snigdha, Saurabh, Arjun, all cameras off.
This is the last.
Huh?
So this is the last class.
Tomorrow is the last class. We'll have tomorrow also.
Okay.
So how can I say 15 by 8 hours? Like, does that count?
15 by 8. Yeah, you can give your answer in fractions. 15 by 8.
Sir, even I got 15 by 8.
So 15 by 8, 1.87 something, I got. Sure.
Okay,
Sir, even
all
I
right.
got 15 by 8.
15 by 8. Okay, few answers with 1 point. Okay, so for people who don't know how to do this, A alone finishes this task of peeling potatoes in 3 hours, which means in 1/3 hour, all right? Sorry, 1/3 of the potatoes. So in 1 hour,
He can do
okay,
1/3 potato, 1/3 of the work.
exactly. So in 1 hour, he can finish 1/3 of the workload, and in 1 hour, B can finish 1/5 of the workload. Okay, and then A and B together will be able to finish 1/3 plus 1/5 of the workload,
8
which
by.
is 8 by 15. So 8 by 15 fraction of the entire workload gets finished in 1 hour. So in how many hours will the full one workload get done, which is reciprocal of 8 by 15, right? So which is 15 by 8 hours, right? In 15 by 8 hours, entire thing will be done. Okay, fairly straightforward, but just wanted to make sure that all of you know. Okay, next one. So 3 circles have diameter, sorry, have the same radius, blah, blah, blah. Okay, so here's a pattern that's given. So I'm not able to find a very convincing
Should I found
pattern.
a pattern? Should I found
Yeah.
a pattern?
So
Sir,
6
me
here.
too.
Yeah, go ahead.
Okay. Sir,
Prashant,
Sir
yeah.
Prashant.
Yeah,
So
go
sir,
ahead, Prashant.
it took me a while, but so the pattern was the figure number plus whole 3 times the figure number minus 1 closed into, like, can I just write it?
So yeah, just 1 second. Just tell me if my pattern is correct. So here in the first, you
So
have
you
a
had
6
times
here.
1, then you had 6 times 2 that to that
Yeah,
pattern,
exactly. So
6
you
times
had 6 and then you add 12. In the third one, you add 18 more. Is that what you were thinking, Arsh?
Yes, sir. So
Okay.
so I was like about to finish this question. It was like 6 into 1 plus till 20, and then plus 20, because what the center circle we didn't count. So it's equal to 6 into 20 plus 19 plus 18 till 1, and then you add 20 more. I think that's the answer.
Okay. But one
Sir?
very simple observation. Yeah,
Sir,
again.
I use the logic here that there's one singular circle in the center, and then outside there's always going to be even numbers because it's
Excellent.
multiples of 6.
Yeah,
So
so,
there's only
sir, I
one
did
odd
that.
number in the options,
Yeah.
which is 1, 1, 4, 1.
So, that's what I did, but I tried to solve it later, like just
Yeah.
in case a situation like this didn't come. And this is the formula that I got. I'll just finish writing it.
Yeah. So meanwhile, while he's doing it, so this is 6 into 1. So here you have 6 into 1 plus 6 into 2. Of course, the plus 1 at the end, right? And we have to be careful. This is figure 3 is going all the way till 6 into 2, right? Which means figure 20 will go all the way till 6 into 19, right? So the figure 20 will have 6 into 1 plus 6 into 2 all the way till 6 into 19 plus this extra 1, right? So which is 1 plus 6 into 1 plus 2, so on till 19. So which is 19 into 20 divided by 2, I believe. Okay. So, and then when you add, what do we get here? 19 times 6 is how much?
How do you do
114.
19 into, like, how do you do 1 till like 20, for example, like 1 plus 2 plus 3?
So
Is that
1
like a
plus 2,
formula
so
for
on.
that?
Okay, thanks for asking me this. I think this is very basic that
Because in
everyone.
the second mock paper also this question
Yeah,
came.
yeah. 1 plus
I
2,
can
so
calculate.
on till n is n into n plus 1 by 2. We covered this a few times in class. Okay. 1 plus 2, so on till n is n into n plus 1 by 2. On that same note, you guys should also know 1 square plus 2 square, so on till n square. That's also a very useful formula, should know. This I don't expect you guys should know, but if you know, that's great. But note it down, guys, for the future. N into n plus 1 into 2n plus 1 whole upon 6. Okay. For example, one of the questions could be, how many squares are there on a chessboard? Not the small 64 squares, but if you include all the different squares. So there are 64 of those 1 by 1 square. There are 49 of those 2 by 2 squares. There are 36 of the 3 by 3 squares and so on. And there are 4 of the 7 by 7 squares. And then there's 1 8 by 8 square. When I add all of them, it's 64 plus 49 plus 36. Of course, these are all small numbers. I can literally hand add them also, but you can use the formula n into n plus 1 into 2n plus 1 by 6. It comes out to be, so this is 12 times 204. So there are 204 squares on a chessboard. Okay, is this clear, Arsh? Thanks for asking this. N into n plus 1 by 2, guys, right? 1 plus 2, so on till n. Okay, and one more, which is very easy
So I
to
have a
remember.
question.
Yes, go
So
ahead.
what is n into n minus 1 used for? N into n minus 1 divided by 2?
That is n choose to. So n
Okay.
choose to, for example, of 15 objects, I'll have to choose 2. That is 15 into 14 by 2. And there's no, okay, in fact, let me deal with a small number, right? So for example, the question is, of 7 objects, I'll have to select 2. So 7 choose 2, which is 7 into 6 by 2, right? But it also happens to be 1 plus 2 plus 3, so on till 6. Because we know 1 plus 2 plus 3, so on till 6 is n into n plus 1 by 2 this way, right? So both are same for 2 different reasons, related reasons, right? So what is 7 choose 2, for example? A, B, C, D, E, F, G. These 7 people are sitting. I have to form teams of 2, right? How many ways can I form? I'll start with A. So with A, it can be with B, A with C, A with D, A with E, A with F, A with G. So there are 6 possibilities with A in it. Now I'll go to the B series. B is already been counted with A, so I won't count it. So B, C, B, D, B, E, B, F, B, G, that'll be 5. So you'll see that it'll be 6 plus 5, so on till 1, which therefore it's 6 into 7 by 2. or 7 choose 2, which is 7 into 6 by 2. Both are the same. Is this clear, Arnav? Right? Both are important and both are same. Matlab, both are same meaning n choose 2 is n into n minus 1 by 2, whereas 1 plus 2 so on till n minus 1 would be n minus 1 into the next number, which is n divided by 2.
Were you able to see the formula for that which I wrote for the circle
No,
thing?
beta, just 1 second. No, I didn't. Where did you send it?
No, I annotated it on your screen.
Oh, sorry. I thought you sent me. Fn plus Fn minus 1 into Fn minus 1. What is this again? I'm not clear. What is this again, please?
This is the formula for like the circles question, no?
Fn plus 3Fn minus 1 times
Figure
Fn.
Fn stands for figure number.
Okay.
So the formula for the number of circles in it, it's the figure number plus figure number minus 1 into that. So I worked it out because, so can you just scroll up once?
Yeah.
I made a clearer version of it. Can you erase the circles that you've
Okay. So I'll erase this. Yeah, go ahead.
So instead of thinking like that, sir, that would like just take forever if you needed to find a big number and there weren't these options. So what I decided to do was that, for example, there are 3 at the. So first I decided to put the flat edge on the bottom. I decided to like flip it thoda sa and I decided to put the edge on the bottom. This side on the bottom, okay? Then it becomes a bit clearer.
Okay,
Then
so
I
like
use,
this. Like this.
This goes on the bottom. Then it becomes a bit clearer that, so it's the figure number 1, 2, 3 plus figure number minus 1 into that much.
Okay.
Just follow the formula. I don't know how to explain it, but
that's fine. And is it working out to be exactly same 1141 that we got?
Yes.
Okay. Excellent.
So you can check. I checked.
Okay. All right. I'll check it out a little bit later. This one. Can you just type it out and send it also later to me on WhatsApp? I'll have a look. Okay. And can you erase this bit? Because I'm not able to erase this, what you have written. Yeah. Okay. Okay. Next one. So this one, okay, we are entering some of the harder questions right now, right? So let's discuss in more detail. Find a positive number such that A is 2013 square plus blah, blah, blah. So obviously the expectation is not to work out this big number and do the square root, but let's use some known formula that we need. So this is A square. So this looks like if I keep 2013 as, oh no, I don't want to keep A here, B, because A is what's being asked. So if B is 2013, then being asked B square plus B plus B plus 1. Right? Uska root. So which means I'm being asked square root of B square plus 2B plus 1, which is just B plus 1. Okay. And therefore the answer I'm seeking is 2013 plus 1, which is 2014.
So that's the answer I got.
Yeah.
So I did it similarly.
Okay. Sounds good. Another maybe a cheeky way you can do is you can look at the last digit. This last digit ends in 9. This last digit ends in 3. This last digit ends in 4. So if at all anything, the last digit of this should end in 6. So something ending in 6 uska square root, the number should end in either 4 or 6. So among the options, there's only one. Nothing else ending in 6 either. So you can be a bit cheeky without actually doing it. But again, I would keep that as a last resort. But will always be lucky.
So why should it end in 6?
Because this is ending in 9. 2013 whole square is ending in 9. 2013 is ending in 3. This is ending in 4. If I just focus on the last digits, 9, 3, and 4, it ends in 6. No, Saurabh? Sorry, I don't know who asked that. Was it Saurabh?
Yes.
Yeah, this is clear, Saurabh.
I didn't get the pattern.
No, the last digit ends in 9, last digit ends in 3, last digit ends in 4. If I'm adding multiple numbers and focus on the last digit, I just have to add all the last digits.
Oh, okay. Now I got it.
Okay, but then that's not very convincing, because what if 2016 was also in one of the choices? because if a number ending in 6 square root can either be ending in the number, the square root can either be ending in 4 or by 6, because either way when you square you get 6. But thankfully you didn't have 2016 as an option. So the better way to do it would be properly like how I just described, b square
So
plus
I
2b,
didn't really understand how you did this
b
above.
square plus 2b plus 1.
Yeah.
Okay, I'll repeat once more. Okay, so I'm seeing 2013 square. Okay, so in my mind, I'm putting, instead of 2013, I'll call 2013 as some number b and see whether I can write out this number in terms of b. So this is b. Therefore, 2013 is b square. So this is b. And this is 2013 plus 1. So it's b square, sorry, b plus 1. 2014 is 2013 plus 1. And now you can see this is b square plus 2b plus 1, right? Which you know is b plus 1 whole square. Is this clear to you?
Okay, yes, sir.
Yeah. Okay, that was question 15. Question 16. 3 numbers are thrown. What is the probability that the product of the numbers is a multiple of 5? Okay, now for the product to be a multiple of 5, at least one of them should be a multiple of 5. But then if you say at least one, it could be all 3, it could be 2, it could be just 1. So it becomes little clumsy to do all of those different cases. So let's do what is the probability that the product is not a multiple of 5, and then I'll subtract it from 1. So I'll say this is 1 minus the probability that it's not a multiple of 5. For something to not be a multiple of 5, none of the 3 attempts should have a 5 in it, right? So each dice gives 1, 2, 3, 4, 5, 6. So none of them should be 5. So each of them should be either 1, 2, 3, 4 or 6. So each of them has a 5 of the 6 possibilities. So the first one should also come out to be not a multiple of 5. Second one should not be a multiple of 5. Third one also should not be a multiple of 5. If we do that, that's the probability of the product of the 3 is not a multiple of 5. And 1 minus that is the answer that we are seeking. So it's 1 minus 125 by 216, which is 91 by 216.
So what if like I'm not sure, like what if something like it's not there, but 4 into 3 into 2 is supposedly 25, and then 25 is a multiple of 5, and then that could be one of
How can a product of 4 and 3 and 2 be a multiple of 5 if neither of them is a multiple of 5? 5 is a prime number. So for 5 to be as a factor, one of them must be 5, no? It's not like 6. For example, I can generate 6 by a combination of 3 and 2, or a 4 and 3, or a 6 and a 1, and 6 and 2, and all that, right? The reason you're able to do it is because 6 is not prime. It is composed of 2s and 3s. Whereas 5 is prime.
So I got it.
Does it make sense? Okay, so can you all repeat the same question with another number? I'll say, so 3 dice are thrown. What is the probability that the product of the 3 numbers is a multiple of 3? Can you guys do this? Instead of 5, I've changed the number 5 to be 3.
So 152 upon 216.
Can you give me the simplest form? Can you reduce it? Because I can reduce this clearly, right? Reduce it if you think this is the answer.
So 76 upon 113.
76 upon 113. 216 का half कितना है?
Yeah, it's the reduced form of
First of all, what is half of 216?
19 by 27.
19 by 20.
Oh, so 108. So 108. Sorry, sir.
I'm putting 19 by
108.
27.
Okay. Even if it's 108, it's not reduced again. Okay. So meanwhile, reduce it. Meanwhile, people have, I think it is what you said is right, but you didn't simplify it properly. 19 by 27.
13 by 54.
Yes, sir, 19 by 27.
Okay. 13 by 54, I had an answer. Any other answers?
So Gyan could have just simply like 4 by 6 could be done to 2 by 3 and then just
Exactly.
I did an error.
Yeah. So it's 1 minus probability that it's not a multiple of 3, right? For it to be not multiple of 3, that means the numbers digit should either be 1, 2, 4, and 5 only. They cannot be 3 or 6. The moment the number has 3 or a 6 in it, the product will be a multiple of 6, multiple of 3. So it's 1 minus 2/3 into 2/3 into 2/3. So it's indeed 1 minus 8 by 27. And yes, Arsh, I totally agree with what you said. He could have simplified 4 by 6 as 2 by 3 at the very beginning itself. Okay, all right. Probability that I'm just thinking another question here. Okay, fine. It's okay, ignore. That is question 16. Question 17 is an interesting one. Let's do this carefully. Okay. Okay, how many ways can the number 10 be written as the sum of exactly 3 positive and not necessarily different integers? Every single word is important, right? Exactly 3 positive meaning 1 and more, right? 0 cannot be, and not necessarily different integers, right? And in which, if the order in which the sum is written matters. For example, he has given a clear example, 1 plus 4 plus 5, which is not same as 4 plus 1 plus 5. But it cannot be 0 plus 6 plus 4, because every one of them has to be positive. And it can be repeat numbers. It can be 4 plus 4 plus 2, for example. So this is fine. And this is not fine because 0 is not included. Okay. So question is clear to everyone. Now, this is a classic chocolate distribution problem, right? So chocolate distribution problem, there are 10 chocolates. So 10 chocolates, and there are 3 kids in a family, right? 3 kids in a family, and dad comes with 10 chocolates. Now, he wants to be fair, at least reasonably fair. So he wants to make sure that every kid gets at least 1. So this goes back to one of the previous homework problems, which we didn't discuss, I think, right? Every kid gets at least 1 chocolate. Okay, so that's equivalent of saying positive numbers, right? In this case, it says sum of 3 positive numbers, which means make sure that every kid gets at least 1 chocolate. And now, how many ways of distributing? Now, what will a good dad do if the 3 kids are sitting here, right? The very first thing he'll do is, first he'll give them 1, 1, and 1, so that they're happy. They won't complain, at least from now on. Now, the remaining 7 chocolates, he can distribute. He can be a little biased. He can give 5 of them to this guy, 0 of them to this guy, and 2 of them to this guy. But effectively, that means this guy has got 1 plus 5. This guy has got 1 plus 0. This guy has got 1 plus 3, 1 plus 2, right? But this is the excess. So this is excess. So this is basic. So he gives them 1, 1, 1 basic, just to make sure everyone is happy. And then excess, he can choose freely. Including 0, he can pick a number. So the problem reduces to, how many ways can I have 3 distinct, 3 numbers adding up to 7. So think of these chocolates as, okay, fine. Chocolates are C, right? So C, 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 C. These 7 chocolates are lying around here. Now, these same 3 kids are there. Now, to distribute them, he must form a couple of partitions. For example, he can put a partition here. He can put a partition here. That means the first kid gets 2. The second kid gets...
Star and bar method.
So the answer is 9 choose 2, I think.
Yeah, 9 choose 2. Exactly,
Right.
Alex. And yes, star and the bar method. Yeah, same
9
idea.
into 436.
Yeah. Okay. So yeah, but for whoever is not aware. Okay. So 2 chocolates for the first, 4 for the second, and then 1 for the last one. Right. And this is extra. Right. And the partition can also be somewhere at the edge. For example, I can be a very biased parent and give one partition here and another partition here. That means the first kid gets 0. The first kid gets anything to the left of the first partition, right? The second kid gets in between the two partitions, whatever is there. The third kid gets whatever is to the right of the last partition. So in this example, 0 plus 6 plus 1. Okay, so ultimately it reduces to, like someone else was saying, you have to put two partitions. I'll call these partitions as P for partition. So this is P for partition, P for partition. So I have 7 chocolates, 1, 2, 3, 4, 5, 6, 7, and I have 2 partitions. Okay, let's say I'll just give an example like this. The partitions are here and here, but literally it's a 9-letter word where I can put 7 chocolates and 2 partitions. So think of it as a 9-letter word.
Now, how do you get it as a 9-letter word?
Because there are 7 chocolates and 2 partitions. 2 partitions because there are 3 kids. So the number of partitions you need or doors that you need is 1 less than the number of kids. Does it make sense? Or separators. By partition, I mean separator.
So like,
So there,
whatever the number is, supposingly I have 50, and never mind, it could be 4 kids, so I'll add 52, choose 52, choose 2.
So if there are 50 chocolates and 4 kids, then I need 3 partitions.
So 52, choose 3.
53, choose 3.
Why 3 part? Like
If there are
50?
you said 4 kids, no? Didn't you not?
No, I said there are 50 chocolates. There are 4 students. So there'll be how much?
53, choose 3, right? Because there are 50 chocolates and 3 partitions needed to separate the 4 students.
Yeah, okay.
Okay, so the number of partitions is 1 less than number of students. So in this case, there are only 3 kids, therefore only 2 partitions are needed. Now I'm laying out all of them as a 7 as a 9-letter word. 7, where is the 9 coming from? 7 plus 3 minus 1. So it's a 9-letter word. A 9-letter word that's composed of 7 C's and 2 P's. Okay, so of the 9 slots, I can choose any 2 places for the 2 partitions. So it's 9 into 8 by 2, which is 36. Is this clear to everyone, guys? Ranbir, are you with me completely? Vanya? Okay. Now, it's a different thing altogether. If the chocolates are different, then it becomes a little difficult problem. In fact, I think one of the homework problems, we'll come to that. One of the homework problems in homework 5 or something, if I recall, was that.
Yeah, in homework 5.
Yeah, I think we didn't discuss it. Let's finish this paper and discuss that, right? It's relevant. Okay, so this is question 17. Okay, question 18 now. Alex and Bob are riding on a circle in opposite directions. Okay, 15 kilometers is the circumference, and they start at the same time at diametrically opposite points, right? So they're starting here and here. So let's say I have a circle here. So one guy is Alex is here and Bob is here to start with. Diametrically opposite positions. This guy goes in clockwise direction and this guy goes counterclockwise. Okay, and they both cycle for 3 hours. How many times do they meet? Okay, so for now, let's not bother where they are. Okay, for now, let's assume that they both start in the same place, going in opposite directions. Okay, now how often will they meet? First, let's discover that. So this guy is going at 35 kilometers per hour, and this guy is going ulta at 25 kilometers per hour, which means they are heading towards each other at 60 kilometers per hour, 35 plus 25.
Relative velocity.
Yeah, relative velocity is the difference between the two, but because the signage is opposite, so it's 35 minus 25. Therefore, at 60 kilometers per hour, they are heading towards each other, right? So the circumference is only 15 kilometers. Okay, so which means every 15 minutes, they'll be meeting, right? Every 15 minutes, they will meet, right? Or rather, every 15 minutes, they will complete one full circle collectively between the two of them. They will meet. Every 15 minutes, they'll meet. Now, you have to be very careful about the edge case, right? And they both cycle for 3 hours. So so this is 0. At 15, they'll meet. At 30, they'll meet. At 60, they'll meet, and so on, right? All the way till 180. Therefore, 12 times they'll meet, but that's if they are both starting at the same point and heading towards. So for example, if A and B were both here, so in this diagram, I'll just draw it in blue here. If A and B were here, and they start in this direction, then what I said is correct. But right now, that's not the case. A and B are on opposite ends. So the very first meet will happen in 7.5 minutes itself. So starting from 0 times 0, they'll meet in 7.5 minutes. Because in 7.5 minutes, what happens? The distance between them was only a half a semicircle, half a circle right now. So they'll meet depending on who is faster or who is slower. Let's say this is the meeting point, A and B. So this event has happened in 7.5 minutes. Thereafter, every 15 minutes, they'll meet. So 7.5 plus 15 plus another 15 and so on, right? So we literally have to count from this point on, but just for convenience, we can count from whichever way you want to count. It's okay. You can literally hand count it, and you'll see the last meeting will happen 180 minus 7.5 minutes, right? 172.5 or something. But you just have to count it. Either you can add 7.5 and then start counting together. So it's 15, 30, 60, all the way till 180. Therefore, they meet 12 times. Yeah, not 11 times, not 13 times, but 12 times. Yeah, Prashast, go ahead, please.
So this is for when they go like against each other, diametrically opposite.
Correct. Yeah. So what Prashast is hinting is probably, what if they are going in the same direction? Then how often will they meet? Then relatively.
Yeah. Then we say.
Yeah. So in fact, let's quickly. In fact, I've not framed the question yet. So this guy is 35 kilometers per hour. This guy is 25 kilometers per hour. So the difference is 10 kilometers per hour. Okay, 10 kilometers per hour. And so right now, A is exactly half a circle behind. So for him to make up this 10 kilometers, right, deficit, relatively speaking, you can just assume B is just static. So you can rephrase the question and say, B is just standing like a sitting duck, right? So he's not going to move. So B is just staying put. A is starting from here, but he is moving at a slow speed of only 10 kilometers per hour, effectively. Because it's the 10 being the difference between kilometers per hour. 10 being the difference between 35 and 25. So if that's the case, so for him to reach B itself, B is, how much is the entire perimeter? 15 kilometers, right? So for him to reach half of the full perimeter, that will take him 7.5 kilometers, right? So 7.5 kilometers, which will take him 45 minutes, right? So 45 minutes for him to reach B. And after that, every 60 minutes, sorry, every 90 minutes, I think. Every 90 minutes, they'll keep meeting. Yeah, correct, Arsh? And then depending on the question, you can work out. For the first meeting, it will take 45 minutes. After that, every 90 minutes. Okay, that could be another question if they are moving in the same direction. Okay, so that's question 18. Question 19. Okay. 4 isosceles triangles border a square of 8 root 2, blah, blah, blah. When the four triangles are folded up, they form a pyramid with a square base. If the height of this pyramid is 6 centimeters, find the area of one of the triangles. Okay, good question. So when all of them fold here, this one, this one, this one, and this one, all of them fold. So from the helicopter, it looks like this. Right? From the helicopter, it looks like this. But if I have to put this in 3D, it looks something like this. The square base is like this, right? And from the midpoint of the square base, I will take it to the top. And if I connect all of those lines here, so the pyramid will look something like this. Okay, so this is how the pyramid will look. Now, he's saying the height of the pyramid itself is 6 centimeters. So this vertical height, so from this top to the center of the square, so this vertical height, that green height is 6. Okay, what else is given? The square base. So the square base, let me also draw it as proper.
Yeah, it's like Pythagorean theorem only, like 8 root 2 divided by 2.
Yeah.
And
Yeah.
then
Yeah. So let's what is the question? Find the area of one of those triangles. So let's say, so let's mark this as A, B, C, D. Okay. Now let's say this is the P is the midpoint of the square base, and then Q is the topmost point. Okay. Now he wants us to find the area of the triangle QAB, for example. QAB. Okay. Now this is given to be 8 root 2. This is given to be 8 root 2. Okay. Now let's find out what AQ is. If you're able to find AQ, or rather, so in fact, let's find out from Q. Suppose I draw a line to the midpoint of AB. So this one. Okay. So let's complete this triangle here. So there's too many triangles here. Okay. So let's call the midpoint of AB as, let me call some M or something. Okay, M. Okay, now I know that QP, which is the vertical drop in green. So in fact, I'll put it in green itself. That way it's clear. So the vertical QP, which is vertical, is 6 centimeters. That's given. Okay, and PM, which is in gray, PM is half of the square, which is 4 root 2. Right? PM is half of the square side, which is 4 root 2, because the entire square side length is 8 root 2. Now, using this, I can figure out what QM is. I can figure out what QM is. QM is square root of,
so it's 4 root 2.
6 square plus 4 root 2 square, right?
Yeah.
Yeah, sorry, you're saying
4 root
something,
2 plus-
Harsh?
Sorry, sir.
You're with me, right? You agree, right, with this? Okay, so this is 36 plus 32. 36 plus 32, which is square root of 58. Am I right? 58. Sorry, 68. 36 plus 32 is 68. Are you guys all with me so far? So if you know QM, then the area of triangle QAB is just half into base into height. So the height is the QM, which is just we found out root 68, and the base is AB itself, which is 8 root 2. Okay, so let's simplify this. So this is 4 root 2 into 68. Root 68 can be written as root 2 into root 34. So this becomes 16 root 34, I think, right? Am I doing some mistake, guys? Why am I not getting
8
matching
root
the answer?
34. 8 root 34.
8 root 34, yes. Correct, 8 root 34. I thought I did a mistake here. Okay, good, thank you. 8 root 34. Okay, is this clear to everyone? How to approach this problem, guys? Can you guys also find for me what is the length of AQ? Find AQ. Which is the slant edge of the pyramid.
Okay.
Can you guys all work it out?
And sir, since the class is just about to finish and so that I don't forget, sir, I just wanted to ask when the results for mock 13 will come.
Sometime tonight. I'm just waiting for those guys to give me all those answers. By tonight,
So
I'll
for
share
me,
it. And tomorrow.
so for me, even the mock 12 results haven't come yet.
Okay, so people have taken in different orders. So whatever collection I have, I'll send it across by tonight, guys. But meanwhile, finish taking all the 3 tests.
Yes, so just send me my score and my whichever questions I've got wrong or right. Because me and my father wanted to discuss.
I've been sending as and when I've been sending to everyone.
Okay.
Sure, but I haven't gotten my mock 12 results either.
Whoever has submitted something and not got, can you just put a message? Otherwise, it's difficult for me to keep track. Here, I cannot keep track. So send me a message. You have attempted something and still not got for more than 24 hours. If that's the case, then send me a message. If you've just attempted this morning and not got it, then hold.
Are you sending it to
Okay.
mail?
No. If you have attempted something and if you have not heard back from me and it's been more than 24 hours, send me a message. Otherwise,
sending the
no, if you have not got your mail, no, on WhatsApp. If you have not got my response with the answer sheet from your test and it's been more than 24 hours, send me a reminder saying I've not got it yet. If not, all of you just hold. By tonight, I'll clear all the backlog. Okay.
I had sent my mock 11 day before yesterday.
Okay, I'm not, guys, understand, I cannot keep track of 20 people, right? If each of you is going to give me something, put me a message, whatever you have attempted and not got it for more than 24 hours. Okay, meanwhile, let's move on. Who has an answer for AQ?
So me.
Okay, what is the answer, Arnav?
Well, according to me, it's 64 root 17.
64 root 17, okay. Doesn't it seem too big, Arnav? Yeah, so this itself is 8 root 34. Now, this should be slightly bigger, but not so much bigger. Okay.
It's like root 68 into root 68 plus 4 into 2 and that answer ka root.
It should not be such a complicated root. Okay, let's work it out, guys. Okay, so we know that AQ square is QM square plus AM square. Now, QM is what we worked out earlier, right? So QM is root 68. We just have it here. So QM is root 68. So this is 68. And AM square is half of the 4 root 2 ka square. 4 root 2 ka square, right? AB is 8 root 2. Therefore, AM is 4 root 2. So AM square is 4 root 2 square. So which is 32. And therefore, 68 plus 32, which is a round number, which is 100. Therefore, AQ is just 10. Right? It turns out to be a very perfect number, 10. Okay, can you guys find your mistake later, guys?
Yes.
Right?
Sir.
Okay, cool. Or am I doing some mistake? No, I'm doing some mistake, I feel, right?
No, so Akrit also got this.
Fine. It's 100. It's 10. Okay, cool. Thanks, guys. Okay, so that's 10. 8 root 34 was the area. Sorry, I got confused with the 8 root 34. Why is 8 root 34 such a big number? Right? The 8 root 34 that we found out was just the area. Okay, cool. Next question, question 20. There are 52 students in a class. 30 of them can swim, 35 can ride a bicycle, 42 can play table tennis. How many can do all 3 sports? No, I think more detail is needed in this one, right? 32 can swim, 30 can swim.
So even I found it rather incomplete.
I solved it. Sir, can I tell how I solved it?
Yeah, go ahead, please, Prashast.
So, how I would solve it, because I got this one wrong. Now I realized. So I would make a bar graph, not a bar graph, a bar chart kind of thing. So 52 students in the class. Then I would at least how many. So then for that, for the at least, so we have to find the least difference. So that's 30 and 35. And then like I'll just read out what I've done just for
Okay, okay, all right. So okay, I didn't notice the thing here. At least how many students can do all three sports is the question, right? So this is 30. So let's say this is 30, 30, 42, and this is 35. Okay, so the total is 52, right? 52 is total. So 52 is A plus B plus C minus A intersection B. Okay, so all right. So A union B union C, the total number of elements will be A plus B plus C individually minus all of the two combinations, A intersection B plus B intersection C plus C intersection A. Okay, plus A intersection B intersection C. Right? So now if this is 52, okay, and this collection is given to be 30 plus 35 plus 42, which is how much is this? 65, 107. 107. Now, at least how many students can do all three sports? I'm thinking if all of them, A intersection B, B intersection C, C intersection A, they're all equivalent to A intersection B intersection C. So all of them either are doing one sport alone or doing all three sports. So if that's the case, 52, no, that's still not working out. Okay, let me just think about this question, guys. I'm not sure whether it's partial information. I'll think about this and come back. Okay, let's move on. 21. How many different triangles can
I
be
solved
formed?
the other question.
Yeah, go ahead, Vishwita. Yeah.
I just found I kind of did it fast, so I'm not like sure exactly what, but
okay.
So there's 30 students who could.
Let me just paste that question again once more. Sorry, just 1 second. Huh? Yeah. Yeah, go ahead, Vishwita. Yeah.
I basically found out 30. So I minus 30, 50, 30 out of 52. So 22 students can't swim. And then 17 students can't ride their bike. And 10 students can't play table tennis.
Okay.
And then I just added all that together. And that was 49. And then 49 minus 52.
Okay. So these cannot play table tennis. Okay. Okay. So these 22, these 17, and these 10 cannot, and cannot. And then what is your logic again? So if
And then I added it all, and then that was 49.
Okay.
And then 49, like, minus 52.
Why is that? Why is that this 52 minus 49 should be able to do all three? What is the logic there?
I mean, it's
So it says at
because then they would not be in any like of these. Okay, I did it kind of fast, so I'm not.
wait. it
Okay, maybe you're right, but I'm not very convinced. Yeah, go ahead, Arsh.
Like they say at least, so like
Correct. They say at
bare
least.
minimum they can.
Grammatical sense, you
So
can just
we are
choose the least
imagining that
option.
all the ones who can do at least like 2 can do 3. So we're assuming like that ways. So it's like not very clear.
So yeah, and in a grammatical sense as such, one could argue that we can just choose 3 because if
So the question could say like the maximum.
no, but like look at the question right now is at least. Supposing even 12 people do it, at least 3 people do it in a way. So it is the question is also grammatically incorrect in a way.
No,
So
basically he's saying
they can replace at least with the maximum number of students that can do all 3 sports.
Yeah. That's true.
rather minimum, no? At the bare minimum, how many people can do all 3 sports? So based on what Vishwita is saying, she's saying there could be even 7 people or 8 people doing all 3 sports. But she's saying at the bare minimum, 3 can definitely do. And that's what I'm
So I just understood
partially
the logic.
convinced. I'm not fully convinced,
I
Vishwika.
just
Let me just
understood
think
her
about
logic.
That's not the bare minimum. That's a
No,
math.
no, I just understood her logic. Look, so if 22 people can't swim, that means 22 people are already removed out of people who can do all three sports. Then 17 are removed out of people who can do all three sports, and in the same way, 10 are removed out of people who can do all three sports. Therefore, leaving only 3 as an option. But the only problem is
But why?
overlapping.
But even those 3 alone, why do you think they should be able to do all 3?
Yeah. So I'm
I mean,
saying
after that, it was
question
just that was the lowest number.
like at least at maximum.
Okay, let me think about this, guys. Okay, and I'll come back. Okay, we'll finish the remaining questions meanwhile. Okay, how many triangles can be formed? But which with a good attempt, maybe very likely you're right also. But let me, I'm not digesting it very clearly. Let me think. Okay, how many triangles can be formed by connecting 3 points in this figure? So how many points are there? 1, 2, so A, B, C, D, E, and then there is F and G, right? So for me to form a triangle, okay, I need to pick either, so I cannot pick all 3 from A, B, C, D, right? I can pick F, G, and one of the A, B, C, D, E, right? So F and G for sure, and one of these. So that gives us 5. Or I can pick 2 points on the line. So 2 points on the line A, B, C, D, E. Okay, on the line A, B, C, D, E. And then with 1 point, one of
F or G.
One of F or G. Yeah. So this would be 5 choose 2 of, and then times F or G, which is 2. So there's 20 ways in this combination, 5 ways in this combination. So total of 25.
Yes, sir.
Right? I cannot pick A, B, C, D. I cannot pick all 3 from the line. I can pick 2 from the line or 1 from the line. Right? And that's it. So two separate cases. Okay, so that is 21.
Sir, I just did 7C3 minus 5C3.
That should give you the same answer, is it not? Or is it not?
Sir, I got same answer.
Got the same answer. Okay, good. That's brilliant. So another way of thinking about it is, so he's saying, where is that? Okay, so without any restriction, there are 7 points. He can pick any 3, but the specific combinations that he doesn't want, if all 3 of them happen to be selected from the line. So 7 choose 3 minus 5 choose 3. So 7 into 6 into 5 by 6 minus 5 into 4 into 3 by 6. That should also give the same answer. 35 minus 10, which is 25.
Exactly.
Yeah. Cool. That is 21, 22. You have enough 2 cents, 3 cents, and 4 cents. How many ways can you make a 10-cent total? Okay, so this, I think we can just hand calculate it, right? Okay, so first let's not worry about ordering. So let's arrange it in descending order. So 4, 4, 2. Okay, that's possible. And then we'll worry about arranging. For now, let's keep it in descending order. So, or we can keep 4, 3, and 3. Okay. And then any other possibility? So average should be 3.33, right? And then that's it, right?
Sir,
so this, yeah. Yeah,
sir, but you can use multiple. You don't
can use
necessarily
multiple.
need 3.
Okay. All right. But that's what I was missing. Okay, so bare minimum you need 3. With 3, you can. This is it. If you have to have 4 of them, I have 4, 2, 2, 2. I can have 3, 3, 2, 2.
Sir.
Yes.
I actually have to go for another class.
That's fine. That's whoever can stick along, please do. I'll almost finish. I just want to finish this paper. Yeah, whoever, feel free to drop off, guys. You don't have to announce. Okay, so 3, 3, 2, 2. Or if I have, I think if I have to have 4 of them, I think this is the only one, right? 4, 4. Yeah, 4, 4, 8. Yeah, and then if I have to have 5 of them, then obviously each of them has to be 2, right? Because the bare minimum is 2. If otherwise it'll exceed 10. Now, for each of them, we can see how many possibilities. With 4, 4, 2, I can have the 2 in the first place, second place, or third place. So 3 ways. 4, 3, 3, same thing. I can have 4 in the first place, second place, or third place. So there are 3 ways. 4, 2, 2, 2. So I can have the 4 in one of the 4 places. So that's 4 ways. So this one, 3, 3, 2, 2. It's 4 characters, of which 2 characters have to be 3. So 4 choose 2. So 4 choose 2, which is 6 ways. And this one, you literally have to have all of them in only one way. So hopefully this will add up. Let's see, 6, 10, 16, 17. I haven't checked the answer, but hopefully it's one of the choices. It should match. Okay, is this make sense? Does this make sense to everyone? Okay, how many more do we have? I don't want to rush also at the same time. 23, 24. Okay, fine. Let's stop here, guys. We'll finish this and then maybe, not maybe. Tomorrow is the last class, right? So we'll try to finish as much as possible. I'll try to go through the basic questions without asking variants. And then at the end, if I have time, we'll come back to some variants. Okay. All right, let's stop here. See you guys tomorrow at the same time, 2:30.
Bye, sir. Thank you.
Bye. Bye. See you.
Bye. Thank
Bye, sir.
Yes, good engagement.